Grade 10, quadratic equations. It's not going to be new to you. You have been solving these for a while already, but today we're going to formalize it, perhaps give it a bit of a definition and revise the concepts involved in solving for quadratic equations. Remember the word quadratic. I hope you are remembering x to the power of 2. A quadratic equation will always have x to the power of 2, and it will always have 2 answers. So you must expect 2 answers. Jot that down. The most important thing about a quadratic equation is that it is of this format, ax squared plus bx plus c. Look at how there's an x squared over there. So I hope you realize you're going to have to factorize. But before you can do that, you need to make sure it's equal to 0. Do not jump the gun. Do not try and factorize trinomials and solve equations, quadratic equations, unless it's equal to 0. Rightio. Let's jump straight into an example. Have a look at how we will aim to trick you. We're not going to give you this beautiful quadratic format up front. We're going to give it to you like this, and you must do some rearranging to get it into the correct format. So let's take our 2x and our positive 8 over, so that we get x squared minus 2x minus 8 equals 0. Woohoo, woohoo. We're in the right format, so we can now factorize. If you factorize that trinomial into 2 binomials, you'll get x minus 4x plus 2. And now, if you think about the concept that if any 2 numbers multiplied together give you 0, then one of those numbers has to be 0. For example, 7 times what number will give you an answer of 0? You can only multiply it by 7. Or 14 times what number will give you 0 as an answer? Only 0. So either the one bracket x minus 4 would be 0, or the other bracket x plus 2 would be 0. If you just want to get into a rhythm, you can just remember when you get to this factorized form, when 2 brackets equal 0, make your one bracket equal 0, or other bracket equals 0, and now you have 2 linear equations that you can solve. Pop the 4 on over, pop the 2 on over, and we get x equals 4 or x equals negative 2. A fun fact is that when you solve a quadratic equation, you are actually solving the x, or finding the x-intercepts of a parabola. Can you remember our parabola is y equals ax squared plus q? It's the same format as this. Look at how there is an ax squared. So if you go to this ax squared plus bx plus c format, this line right here, you can see that this ax squared, there's an invisible positive 1 there. So this would be a happy smiley face parabola going through x equals 4 and x equals negative 2. This is just a fun fact. This is just for you to relate equations back to functions. We won't be testing it like this really this year, but next year, once we start shifting our parabolas left and right as well as up and down, you'll definitely be asked to sketch something like this in the bottom right. For now, I just want you to see, oh, that's what I'm actually doing. I don't expect you to be able to sketch this, but I do want you to realize that when you solve a quadratic equation, you're merely finding the x-intercepts of a parabola. Another 2 words that are often approached with trepidation is the word root and solution. Root and solution are exactly the same as x-intercepts. Those 3 words are all synonymous. They all represent the same thing. So if I asked you to find the roots of this equation, I'm basically asking you to solve for x. So your final answer is called a root, it's called an x-intercept, it's called a solution. Get comfortable with those words. Right, this example is another one where we're seeking to trick you. You may think, this is factorized already. So I can already say either 2x minus 1 equals negative 2 or x plus 2 equals negative 2. Wrong, 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 wrong. Please do not fall into that trap. We're setting it up so nicely. There's camouflage all around it. You will fall into this trap if you don't remember that you have to create this quadratic equation into the correct format. In other words, we desperately need that equals 0 on the one side of the equation. So now what on earth can we do to change this thing up a little bit and get a 0 on the right-hand side? Can we perhaps FOIL out, multiply the brackets out, distribute them, and then take the -2 over? Let's do that thing. So first times first, outer, inner, last times last gets us this quadratic expression. It is not yet equal to 0. So in our next line, we need to get that -2 to the left-hand side. And so we now have a 0 on the right-hand side. Whoop, whoop. -2 and +2 cancel out. So we get 2x squared plus 3x equals 0. Beautiful. Now we have a highest common factor of x, and now we have a product. We have factorized this thing, so we are ready to jump into our answer. X times 2x plus 3 equals 0. So either x is 0 or 2x plus 3 equals 0. X equals 0 is the one solution. No need to work further on that. But 2x plus 3 is now a linear equation that you can solve for x. Kick your 3 on over, it will become -3. Divide your 2x by 2. What you do to the left, you do to the right, you'll get your final answer as -3 over 2. Just for interest's sake, I'm reminding you that when you are solving a quadratic equation, you are merely finding the x-intercepts of a parabola. So that's what this parabola would look like. It's also a happy-shaped parabola because when we got to this format over here, the a value, the coefficient of x squared was positive. So this is a happy parabola going through those 2 points. Not really important for now, but I think you have what it takes to see the link, which is quite exciting. This equation might look quite similar since we have recently dealt with equations involving fractions, whereby we often need to find an LCD. But first, we need to realize if you've got a fraction, that denominator is not allowed to equal 0 because it will make the entire equation undefined. So just pop your restriction in the corner of your page and then go on to find an LCD. This one's easy peasy because x can be written over 1, -7 can be written over 1, and now it's very clear to see that your LCD is x, so we need to multiply each term with an x. This 1 needs to be multiplied with an x. What you do at the bottom, you do at the top. Likewise for the 7. So I am being cheeky. I haven't shown my multiplication, but I have dropped my denominator by multiplying every single term with x. The 30 doesn't gain an x because it already had x as a denominator, so I left that untouched. This x was multiplied by x. This 7 was multiplied by x. And now are we super close to the correct format? Ax squared plus bx plus c equals 0. Please don't try and factorize the left-hand side yet. Take this 30 over to have the correct format. And now we can factorize into 2 brackets. Either one of those brackets equals 0. And voila, we get our final answers, which, just for interest's sake, represent the x-intercepts of a parabola that you won't need to sketch this year, only next year. Last example for this session is a word problem. Don't be intimidated. Don't overcomplicate the situation. Try and always stick to one variable for such word problems. Let's have a look. The perimeter of a rectangular room is 18 meters. You know what a rectangle looks like. You know how to calculate perimeter. So we can perhaps use this 18 and set up our own equation in terms of x. Let's have a look. It does help usually to make a sketch. It's more a visual aid can help you with setting up your equation. Let's think. If they tell us the width of the room is x, it means the shorter side of the rectangle, the breadth is x. Width and breadth is the same thing. And then I just want you to realize the longer side of the rectangle is length. The one piece of information we have been given is that the perimeter is 18 meters. But let's think about the perimeter. If you were to work it out, wouldn't you add x plus length plus x plus length all together to get your perimeter? Of course you would. That's pretty simple. We are now looking for length in terms of x. Do we have a value that I can replace the word perimeter with? Yes, we do. 18. And at the same time, I've just gathered my like terms. X and x together gave me 2x, and length together gave me 2 length. You could have used another variable for length, like y or z, but I like to be, I don't know what, it just seems, I like to use wording because it seems real to me. Then I always remember this is the length that I'm working out. If you introduce another variable, you run the risk of overcomplicating this equation and confusing yourself. Now let's get 2 length all by itself by taking out 2x over, and I don't want 2 length as my answer. I want length all by itself. How do we get rid of a multiply by 2? We divide every single term by 2. So length in terms of x is just 9 minus x. So instead of length, I can write 9 minus x there on my sketch. Now what if, oopsie, my animation has popped everything on at once. Apologies, just follow my laser. If the length of the room is increased by 3 meters and the width is increased by 1 meter, then the area of the room will be 36 meters squared. Now I ask you to solve for x. So let's write a new length because we've increased the dimensions of this room. The original length was 9 minus x. But the question tells me to increase this dimension by 3. So 9 plus 3 gives me 12 minus x. So that's the actual length now that we're dealing with. Then the new width, it was originally x, but they said it's been increased by 1 meter. So our new width is x plus 1. Now, if you can remember that length times breadth, or length times width, remember width and breadth are the same, the area is given by length times breadth. So can we perhaps take 12 minus x in a bracket and multiply it with x plus 1 in a bracket, and then equate it to the area that they've been given, that we have been given? So 12 minus x in brackets times x plus 1 in brackets equals 36. Set that equation up for yourself, solve for x, and let me know the answer that you get. I want you to do the rest, and I will let you know if your final answer is correct or not before you move on to the homework for today. Enjoy and thank you.